Experimental probability is when you have the probability, the number of times the event occurs over the total number of trials, meaning the number of times it happened versus how many times you tried. So here we have you spin a coin 25 times. And of those 25 times, it lands heads up 6 times. So we plug it back into our formula and we ask ourselves, what is it that we're looking for? If we're looking for heads up, it's the number of times the event occurred. So how many times did it land heads up? 6. Now next, how many total times of trials? How many times did we try to spin it? 25. Now of course, the next part is how many times did it land tails? So 25 minus 6 is 19 times. So we have 19 times for tails. So we ask ourselves again, the number of times the event occurred. So if we're looking for tails, then we have 19. And what was the total number of times we tried? We tried 25 times. So let's do a problem. So let's say a teacher has a bag full of marbles. And there's 30 students in a class. So she walks around each student, and each student pulls out 1 marble. These are the results of that. So the students pull out 3 blue ones, 12 green ones, 9 red ones, and 6 yellow ones, totaling 30 students for 30 marbles. Now, I want to know the probability of blue. So we ask ourselves, how many times did blue happen? We look up here, 3. Next, how many total times of the trial? 30. We're going to reduce to 1/10. Now, same problem, only we're going to find out the experimental probability of green. So we ask, what's the number of times the event occurs? 12. What's the total number of trials? So we put 12 over the total number of tries. So 30 students for 30 marbles. So we reduced that down to 2/5. Next, let's go with yellow. So we ask ourselves, how many is the number of times the event occurred? 6 times. How many total number of tries? 30 students, 30 marbles, which then reduces down to 1/5. Next, let's do red marbles. So we ask ourselves, what was the number of times we pulled out a red marble? 9 times. Out of 30 tries. Which is then equal to 3/10. So let's look at an example of experimental probability in action. So same problem as we were doing, but the teacher at the end of the day says there were actually 50 marbles in the bag. There was only 30 students, but they pulled 30 marbles out of a 50 marble bag. So we're trying to figure out how many red marbles there were in the bag. So we look at red, and we already found out that there was 9 out of 30 out of the marbles that were picked out of the bag. We reduce that down to 3/10. So in order to find what the experimental probability is for 50 marbles, all we do is multiply by 50. So we multiply by 50 and we get 150 over 10, which we then reduce down to 15. So 15 is our answer. There were actually 15 marbles in the 50 marble bag. Next, we're going to move on to theoretical probability. This is different than experimental probability. So theoretical tells us more what's supposed to happen. Think of it as what's supposed to happen. Think of experimental as what actually happened. So our formula for this is the number of favorable outcomes over the number of possible outcomes. So favorable outcomes are what I would think of as what you're looking for, what you're looking for to happen, what you want to happen, and this is what could happen. Out of all of our options, that's what could happen. So in our next problem, we're given these letters: E, L, X, O, P, E, and R. So our job is to find the theoretical probability of finding a vowel. So remember, a vowel is A, E, I, O, and U. So we have E, so that's a vowel. So there's one. O, that's a vowel. That's two. And E, that's a vowel. So there's three different vowels. So I want you to think the number of favorable outcomes. So we're looking for vowels, and we just found the number, not what they were, but the number of vowels. So we had 1, 2, 3 different vowels. What's the number of possible outcomes now? Think there's 1, 2, 3, 4, 5, 6, 7 tiles. So if we were to throw those all in a hat, and we started pulling out different tiles, we're supposed to pick vowels 3 out of 7 times. So same problem, we're going to do the opposite. Instead of finding vowels, we're going to find consonants. So consonants are simply what aren't vowels. So let's see which ones are vowels. E, no. L, yes. X, yes. O, no. P, yes. E, no. R, yes. So we have 4 different consonants in our tiles. So the number of favorable outcomes. So remember, favorable is what we want to happen, what we're looking for. And we're looking for consonants. We're trying to find the number of them. So we had 1, 2, 3, 4 consonants that we can choose from. Now, the number of possible outcomes. We covered that in the last one. There's 7 tiles. So our theoretical probability is 4 over 7. Now, we're on a new problem. I believe this is number 10. So what we're gonna do is we're gonna find the theoretical probability if we spin a wheel 18 times. If we spin a wheel, it has 18 spots that are possible and 6 spots that you can win in. So once again, 18 spots possible, 6 winning spots. So if we're trying to find the probability of winning, the favorable outcome, that's the one we want to happen, the one we're looking for. And if we're looking for winning, we know there's 6 winning spots. Now, how many number of possible spots are there? Well, we already found out there's 18 spots on the wheel. So, like I said, 6 winning spots. So we're looking for winning. So we put winning as a favorable outcome because we're looking for winning. And there's 18 spots total. Now we reduce to one third. So 1/3 of the time you're going to win, theoretically. So now we're going to compare theoretical and experimental probability. So I'm guessing you're a little bit confused on what's theoretical, what's experimental. So hopefully this helps. So what we're going to start with is what's the theoretical probability of an even number. Of an even number. So the way we find that is, let's say we rolled a dice. And these were the possible outcomes of that dice. Because the dice has 6 sides. So let's say these are all equally likely. That no matter what, whenever we roll, we could roll any of them just as easy as any of the others. So even numbers, we're looking at this one, and this one. Those are all the even numbers on our dice. So let's find the theoretical probability of an even number. So the way we do that, if you remember right, is we put the favorable outcome. So we're looking for, what are we looking for? Even numbers. So we're looking for even numbers. So there's 3 even numbers. Over, how many possible outcomes are there? 6. So once again, the favorable outcome, or what we're looking for, what we want to happen, we're looking for even numbers. So we count off how many evens do we have. 1, 2, 3. So we put a 3 on top. The bottom number is how many options we have. So we have 1, 2, 3, 4, 5, 6 options. So we put a 6 on the bottom. We then reduce that to 1/2. So the next part asks us to look for the experimental probability of evens. So, experimental of evens. So we'll just go ahead and write that out. Now look back on your sheet and find what experimental probability looks like. So the top is the amount of times the event actually occurred. So let's say we rolled our dice 36 times. So we rolled our dice 36 times. 1, 2, 3, just kind of like the spinner activity you guys did earlier in the week. So we rolled the dice. These are the results that we actually got when we rolled the dice. So we're looking for even numbers, so identify the even numbers. So we have those even numbers, and we're looking for what they actually rolled. So a 2, we actually rolled a 2 3 times. So we rolled it out of our 36 times. We only rolled a 2 3 times. Next, the 4. So we find out how many times did we roll, and we got a 4. And it said we rolled it and got a 4 6 times. The last one, 6. So we rolled a 6 6 times. We rolled, we got a 6 out of our 36 times 6 times. And the bottom of experimental probability is how many times did we try to make it happen. So like I've been saying, we rolled our dice 36 times. Because if you add all these up, you would get 36. So when you get 36, after adding them all up, you would put that on the bottom. So now, of course, we find out how much that is. So if we add the top, we get 15 over 36, which is then equal to 5/12. So the last part of comparing is we're going to look at our results. So on the left, this is our theoretical probability. On the right is our experimental probability. So let's look at those numbers. First, which one is bigger? So we would find that by setting them both equal to 12 on the bottom, and we find that 1/2 is actually bigger. So I'll remind you, this is what's supposed to happen. This is what actually happened. Supposed to happen, actually happened. Supposed to happen, actually happened. So theoretical, we were supposed to get an even number half the time. So 50%, however you want to look at it, but half of the time. Every other roll should have been an even number. Here it says, actually, we rolled less than that. So we got less than half when we rolled all of our dice. Okay, after you've watched the video, here's what I want you to do. But you can't tell anyone. Don't tell anyone at all, and see what happens in class. So I want you to go over by the calculators, and there's worksheets tucked behind the filing cabinet. Once again, over by the calculators, tucked behind the cabinet. Now, don't tell me. Don't tell anyone. But when you're here, just get up and go over there.